Hello, welcome to CS Wilson Draws Live. This is my first official live stream. Yeah, exciting stuff. So anyway, already locked up. Okay. I just want to thank everybody who's tuning in live to watch this. I thank you. If you are not tuned in live right now and you want to watch it later, it will be up on the channel. If you want to view it then, that's absolutely no problem at all. You can see everything that's going on. I don't know how often I'm going to be doing these. This is something that is new for me, doing a live stream. So I'm actually wanting to do some Tekla stuff here in just a little bit, but we'll get into that in just a little bit. These may be more frequent. These seem to be a little bit easier to put together than doing an actual edited video. So we'll see how that works out as well. So if I'll do them more frequently, hopefully, if depending on how well they go, and if there's any interest in them, I'll do them probably more often, and also the availability of my time. So that's the other part that seems like these would be a little bit easier put together. So and which means I could probably do them a little more frequently. I don't have a solid format yet as to how I'm going to do these. I do have an idea. I didn't just turn the camera on and start recording. I do have some idea of how I want the live stream to go. I think it's probably going to be something more this format where we start off with news and announcements, anything relative to the channel or relative to Tekla Structures, or just whatever I feel like talking about at the very beginning, and then maybe go into show some techniques or methods with Tekla Structures, just switching over to the desktop and just showing how to do stuff with Tekla. Or with something else maybe too. Who knows? Who knows where it'll go? And then maybe afterwards doing a question and answer on what was just shown, or questions and answers for anything really. But we'll open it up for that to have the interaction between me and the viewers, and actually between the viewers amongst themselves, which is encouraged. Always encouraged. Just please try to keep the chat clean, and let's be civil. So as far as questions and comments go, if you are watching live, you are free to chat away. If you leave comments in the live chat, I do see those. Everybody else can see them as well. I'll try to respond to them as I'm able to. And if you're not watching live and you have questions or comments, if you're watching this after the live stream is over, feel free to leave your questions or comments in the comment section below. I do read those, and I try to respond to them as much as what I can. So with that said, we're going to try to keep this one short today. It's going to be a very simple how-to, because just to make things easier for me, and just to kind of work all the kinks out, and to try to work the bugs out of the system as much as possible. So we're going to switch now to the how-to segment, and in this particular one, I'm going to show how to model a Class 150 raised face weld neck flange, which is something that I've had to do in a recent project, and I figured out how to do it, so I thought I would show you how to do this. And it's more, the intent is more to not necessarily how to draw this particular weld neck flange, but to show that there's a way that you can create assemblies or parts from native profiles in Tekla, and then create them into, or put them all together to be one part. And so there's a way to do that without having to bring something in from the outside as an item or a reference or something like that. You can do it right inside of Tekla, and there's all kinds of profiles in order to do this. So you just have to be creative with it. So anyway, we're going to get started with that, and to do that, we'll switch over to the desktop, where I already have loaded up here. This is a project that I'm currently working on, and in this I've had to draw and model these pieces right here, which are the raised face weld neck flange. And if you're not familiar with industry or industrial piping and things like that, it's a pretty common part. So anyway, I'm going to take one of these, and you can see this is what I've been modeling here. This is a bulkhead. There's two bulkheads. They're actually the same except for this little piece right here that bends over. We got one that bends in here and one that bends in there. Other than that, they're both identical, but that's beside the point. So I'm going to take this piece right here, and I'm going to copy it. We'll just put it right out here so that we can see it. And when I do that, you can kind of see where we have a cut in there, and you can see where some of the parts are here. And we'll get into that here in just a minute. But for right now, whoops, that's not what I wanted to do. For right now, that's not what I wanted to do again. There we go. So this is what we're going to be modeling today. This is basically made out of three separate parts. I have the face here, which is the raised face, which is a part, and then I have another part here, which is the flange, and then of course in the back we have another part which makes up third part, which is like a tapered cone kind of object. It's an elliptical object, but we'll get in. I'll also get into that here in just a minute. And then they're all put together like an assembly. So we'll start off. I'm going to come over here, and this is the plan view of that. And we're just going to slide over here to grid B, and we are going to get started drawing this. And the first thing that I'm going to draw is the flange itself. So that's this large outer diameter piece here. So we're going to start with that. So I'll pick up my beam command. I'm going to hold down the shift key and pick up my beam command to bring up the beam properties. And I have a property already set for this, stored away. It's 4RFWN for raised face weld neck. So we'll load that in. And I don't know how well you guys can see that. I had trouble seeing it before, so I'm going to turn on the magnifier here, and that's basically what I've got. The part in the assembly marks you want to set on this particular piece. This is going to be our main piece, so I want to set everything. I want to make sure everything is set for that. And it starts off with I do call it PF, which stands for pipe fitting, and then the start number can be whatever you need it to be. The assembly is not necessarily important because it's actually going to be a part. It's not going to be an assembly. And then the attribute, as far as the name goes, I give it something that I'll remember, and then the profile we'll get into in here. The material can be whatever you need it to be, and the class, of course, is for the color. And the positions on all of these are basically, since it's a round piece, I'm going to make them all for the middle, so they're all going to be in the center here, which make it easier to draw. The other thing is with the user-defined attributes, which are over here. I set these up, the parameters. These that I'm working with in particular happen to be stainless steel. So in the comment, I have everything, my templates and my reports all set up to read the comment if it's there and put it before the profile name, or in this case, the name of the buyout object. This is also a buyout. But anyway, I have that set up. So these are stainless steel. I use user field 1 and 2 when it's a buyout in my templates and my reports, that if it is a buyout, and that's set to yes, then it uses user field 1 and 2 to list it out in the bill of material or on the in any report that I happen to have. I also use that on the drawings if I need to call it out in the drawings. That's where it comes from. I take those two user fields and go from there. So that's what those were. So there is our object, and the profile that I'm using is, you can use any round profile that you want. I'm going to go back out of this. Oops. I'm going to go back out of the magnifier. You can use any round profile that you want. If I go into the profile, to select a profile here, I'm in the circular sections and in the round, and basically any of these, round bar, rod, whatever you want, it doesn't really matter. I use D because it's generic, it just stands for diameter, and it's just an easier one to, I just make everything that, and it goes much easier. That way everything's kind of standard. So we're going to use that, which is a 9-inch diameter plate. So I'm going to give a point. Now the other thing, and I forgot to start off with that, is that we do need to know some dimensions here before we get started. So I have a chart. Oops, not that. I have a chart, which is here. And this chart shows all the dimensional properties of the pipe flanges of these particular ones, these weld neck pipe fittings. And they start from the size 1/2 inch and they go all the way to 24 inch. I've messed with all the different sizes in betweens. What we're using today is this one right here, which is a 4 inch. And this gives all the dimensional properties. And you can see on this chart that there's all kinds of little ins and outs up on the towards the end. There's a little grind that they put around it so they can weld a little welding bevel in there. There's also some of these other different kind of slope in there. I don't normally show those. I'm showing pictorial, but as accurate as what I can, but still kind of basic and pictorial. So I ignore those. You could, if you wanted to, show them exactly the way that they are. That would be no problem. It's absolutely doable. But for this example, we're not doing that. So we start off with the 9-inch, where I got the 9-inch diameter, is from the outside diameter of the 4-inch pipe, which in here is 9 inches, and that's the total overall outside diameter. So that's where the 9-inch came from, and then now we need to also know what the length is, and the length on this one in particular is going to be the T dimension, which is up here, which is the thickness, and that includes the raised face. So it's the T distance minus the thickness of the raised face, which happens to be, for most of these, is about 1/16 of an inch, so we're going to figure 1/16 of an inch. So the T distance for this is 0.94 inches minus the 1/16 of an inch gives us 0.8775 inches, and that's what we'll use to draw this with. So we'll close that. So we start off, we give a point, and I'm going to do this in the plan view here. I'm going to give a point, then I'm going to push my cursor to where it's 90 degrees, and I'm going to type in 0.8775 inches. And that gives us our first piece. Yay. Okay, we got our first piece drawn on there. And then while I've got this all set up, and I've got this going, this is the only piece that I'm really concerned about, of having all of the information from the user-defined attributes and all of the things that we had defined in the beam itself, the part prefix and the part start number, the name, all of that other stuff. I want that set to this because this is going to be the main part. Everything else is kind of inconsequential. So the next thing that I'm going to draw on here is the raised face itself. And the raised face, and this particular one, if we load up the PDF here again, the example, the faces, we want to know the diameter, and in this particular case, the diameter is R, which is 6.19 inches. So we need to set a profile up that is 6.19 inches. And then the thickness is going to be 1/16 of an inch, which is typical for most of these raised faces, and it also says that right here, that it is 1/16 of an inch. So we're going to take our same beam properties that we had here, and I'm going to go ahead and pick up the beam command and get that activated. And then I'm going to set my diameter to be, and I'm going to put in the actual decimal, 6.19 inches. Now, when you put in a decimal, when you put in the decimal in a profile or pretty much anywhere, now I'm using U.S. imperial fractions here, U.S. imperial dimensions. Whenever I put in a profile of 6.19 inches, when I hit enter or I go out of this into another, it changes it to 6 3/16. Now, is it exactly 6 3/16 inches? No, it is still actually 6.19 inches, and I'll show that here in just a minute. We can check that so that you can still put in decimal. You can still be precise and still put in decimals, even though it might change it over. The appearance, it looks like it's different, but it's actually the proper dimension. So now that we have that, we're going to apply that, and I'm going to come back here to my plan. I'm going to give a point, and then I'm going to pull my cursor out so that it's perpendicular, and then I'm going to type in 1/16 of an inch. So that gives us now our raised face in there. And to show you, if I do a dimension of this right now, it's going to tell me that that is 6 3/16 inches diameter. However, if I go into, let's see, what if I go into settings, options, and units and decimals, and I'm going to change my length here to be decimals of an inch. We'll apply and OK. We'll go ahead and redraw this, and I'll put another dimension on here. Oops, here. From here to here, and you can see it's 6.19 inches. I don't know if you can see that, so let me zoom into it. You can see that it is 6.19, even though the actual, if you try to list out what that part is, it's going to tell you that it's 6 3/16 diameter, but it's not. It is what it needs to be. So you can still draw precision with these. You can still draw precision even though it may not appear that you are. So the next part that we want to draw is the actual. So now we have the raised front. We now have the raised flange. And actually, before we get too far, I need to change my system back here. Settings, options, units and decimals. And we're going to change this back to feet and inch because that's what I'm used to working with. Okay. Now but actually for this example, probably could just leave it as decimals of an inch because that's what everything is in. So the next thing I want to draw is I want to draw the actual weld neck. And the weld neck for this is kind of a special profile. So I'm going to come in here to my beam properties again, and I haven't closed it yet. We're still using all the same properties. I'm going to come up to beam, and we'll get my beam started again. And this time for the profile, instead of using a diameter, because it's not an actual round piece, you can see it has a taper to it. So we want to show that taper, and with that I'm using a different entity, different profile. So if I come in here, and now instead of using the round profile, I'm going to select an elliptical profile, and there's only one in there, so we'll use that one, and it's ELD. And essentially what ELD is a solid piece. You can make it a cylinder, but it has more, it's a solid piece that has a diameter at one end and a diameter at the other end. And it actually has diameter in two directions. So you can make it an ellipse, like a width and a length, if you wanted to make it elliptical, and it has that on both ends. So if you want to make them round, you just make the width and the length the same on one end, and then make the width and the length the same on the other end, and it will convert it into like a cone that has the top cut off of it. So I can't think of what the name of that is, but you can do that. So for this particular one, we go back to our page here, and the distance that we need to find out what the large diameter is and what the small diameter, what it's tapering down to. So those dimensions are X for the long, or the large dimension, And for this one, it is 5.31 inches. And then what the A dimension is, which is the small diameter, which in this case is 4.5 inches or 4.5 inches, which is also the same diameter of the Schedule 40 pipe that this fits onto. So that's the same outside diameter of the Schedule 40 pipe. So we're going to go with that, with those two dimensions there. So 5.31 down to 4.5. The other thing we need to know is the length. And in this, you have to do a little bit of math again. It's Y, which is the total length of the fitting, which in this case is 3 inches, which is right here. And we want to back out the T dimension, which is 0.94 inches. And when you do all of that, it becomes 2.06 inches. And again, we will use that decimal to be precise. So those are our dimensions that we're going for. So we're going to start off here, and I'm just going to put this in where it's easier to input here. So D1 and R1 are going to be the start point, because it's number 1. That's where we're going to start. So I always look at it that way. It's also depicted this way as being in this chart here, and I'll show you the chart if you can't see it. So you can see that the D1 and the R1 are the larger diameter, and that the R2D2 is at the R2D2. I never noticed that. I just said that out loud. I think when you say things out loud, you notice things. I never noticed that was R2D2. Okay, so that's funny. So and that's going to be, since that's the second one, that's going to be the end, the end point. So R1D1 on the large end diameter, and R2D2 on the small end. See, now I can't stop but thinking about R2D2. All right, so for our D1, we're going to put in the actual diameter of what it was, the decimal, so 5.31 inches. And you're going to see it switch over to what it rounds it up to for the U.S. Imperial. And then I'm going to put in the same dimension for the R1. And then R2 and D2 here are both 4.5 inches. And that now has our parts set up. So that's going to show those. I'm going to hit apply and OK. And now we can draw this, and we've already determined through math that the length is going to be 2.06 inches. So I'm going to give a point right over here. I'm going to give a point right in the middle, and I'm going to shoot up so that I've got a perpendicular line. I've got my ortho on for this whole thing, by the way, if you hadn't figured that out. So now we're going to go 2.06 inches. And that there, because I didn't hit the apply. So there, that is the part that we just put on there. It starts off at the 5.31 inches at the large end and tapers down to 4.5 inches. So here we have the basic shape of our flange, of our Class 150 raised face weld neck flange. So now what we need to do is two things. We need to put a hole in it, because it's really not any good without the hole in it. And for this particular one, it uses, it's called the bore. And what I do for that is fairly simple. You can do this with a lot of pieces, and probably have already done this. You probably already know how to do this. You want to set up I want to cut a hole through this, and I don't want to put a hole like from the bolt system. I want to put I want to actually cut and remove parts of remove these parts. So the way I do that is I have a setting already, and it's just called round hole. And basically this sets everything up to be cut. So it's called a round hole. The part name is called cut. The name is called cut part, and it's anti-material, so which is one of the materials that are set up from Tekla out of the box. It's basically a zero weight material. And then the profile can be, you know, any of the round, again, any of the round pieces. Now for this I'm going to use the D part again. And for the bore on this, it comes from that chart. It also comes from what the inside diameter of a Schedule 40 pipe is, which is a standard bore. And for this one, that distance or that diameter is actually 4.026 inches. So for this, I'm going to use the same diameter, the D profile, and then put in 4.026 inches. And so that I don't make you guys sick with this thing moving all over the place, we're going to close that. And then to make sure that it did it right, 4.026 inches, and then we'll hit apply. And then we're going to pick up our beam command, and I'm going to draw this piece. I'm going to give a control point right at the middle of this, and I do this by holding down the control key and giving a point. And what that does is, it looks like I've given an actual point, but I haven't. It's called a control. I call it a control point, and it's waiting for the actual first input point. So that gives me a way that I can give a point and then reference from, and then I'm going to go up again straight with ortho on, and I'm going to go about 1/4 of an inch. You can go any distance. That doesn't really matter. And so now I've given my first actual point. And now I want to go down this way, so that I'm going to go through all of this piece. If you want to, you can get fancy. You can hold the control key down and give a point there, and then measure down 1/4 inch, and so that you're 1/4 inch on either side. This doesn't really matter. It can be any length as long as it's in the center. So now we have another profile here that's cutting right through everything. But it's not actually cutting. They're all interfering with each other. So now we want to make it a cut. So the way I do that is I come up to my part cut, which is where you can cut one object with another, with a part, or with another. You cut one object with another one, or multiple objects with another one. So we're going to activate that. And what it's asking me for is to select the parts, or the part or parts to be cut. And you can select multiple parts, but you have to window them in. The way I have it set up, and I think most people do, is if I window in from the right to left, if I go that way, so in other words, if I go from here over to here, anything that falls inside this box is going to be selected. If I go the other way, let me start this again. If I go the other way, and let's say I go from left to right, and I try to select something in here, it's going to tell me that there's nothing in the box, because when you go from right to left, anything that falls inside that box will be selected. When you go from left to right, the entire part has to be inside that box in order for it to be selected. So the way that you can select multiple objects is to go from left to right, or right to left, I'm sorry. It makes it much easier. So that's what we're going to do. We go from left to right. This is called a crossing box, and it selects those pieces. Now that they're selected, I can now select the part that I want to cut those pieces, which is going to be our new cylinder that we just drew here. Now when I do that, you can see that there's a new entity that's been created, which is the cut. And it leaves so it cuts the parts, and the parts have been cut, and it has confirmed that, told me that it did that. But now we have to get rid of the original part, and we just go in here and we want to select the part that's in the middle, which is the beam that we drew in there, and you just delete it. Now when you delete it, it leaves the cut that's left behind. So now we have our hole in the middle here. So that's how you cut parts with other parts. It's actually very simple and very useful. So now we have basically we're getting there. The only thing we have left to do now is put the holes in, but this is the basic shape with the hole in it and everything. And if you want to be able to select you can see how I'm rolling over the cut here, and I'm able to actually select it. And if I do, I double click on it, it brings up all those things that I had brought up before, or what I'd used to actually draw that with. If you want to be able to select those, down in your toolbar, down in here, there is it looks like a pair of scissors, and if you select those, it will allow you to select the cuts. If you have that turned on, you're not able to select the cuts, and sometimes you have to turn that off in order to delete the entities that you cut with, if that makes any sense. But if you're having trouble selecting just the entity to get rid of the entity and leave the cut, turn the cuts off, and so you can't select them, and then you can easily delete the cutting entity itself. So we're going to clean that up, and the next thing we're going to do is show the bolts, or show the holes for the bolts. And what I like to do with these are I like to use the bolt system to do this. So what I want to show here is, first off, the holes that we're using. In this particular flange, we use this information over here. We have on this flange there are 8 holes. They are 0.75 inches or 3/4 inch diameter holes, and then the bolt circle or the diameter of to the center line of holes is 7.5 inches. So with that information, we're going to go back to our piece here, and now I need to get a clean view looking right straight into the face so that I can put the bolts in. And in order to do that, I'm going to create a temporary section. I have one already set up as standard. It's also called temporary section, that I can load up, and then I apply that, and then I'm going to create a new view using 2 points. And I should probably not. I have macros set up on my keyboard because I use these all the time, so I can easily do that. But basically, it's if you go into view, you start a new view, you pull that down, and in here there's one that's called using 2 points. And if you do that, it's the same as like cutting a section where you just give 2 points. So we'll select that. I want to go right across the face here, so I'm going to go from the point there and just go right over, make sure that I'm ortho, so I'm looking straight into the face. And this opens up a new view, which is here. Looking straight into this. There's the one that we have, our example, and this is the one that we're creating. So let me zoom into this one so you guys can see it. Let me kind of enlarge it here so you guys can see it. Once I've created this, the other thing I do is I hit G10, which sets my my work plane. But the other way you can do that is if you go up here also in the view menu to work plane, and you pull that down. And I always use parallel to view plane, because we've just created a view plane here, and I want to now create my work plane so that I'm working in this view with it being the way that this I want to work in this view right here. And I want my work plane to be set to that. So I say parallel to view plane. And then you just give a point somewhere in the view that you want that to be. And you can see here that now here's my work plane with the X and the Y. I'm now working in this view. Everything is set up for this view. So now I want to put my bolts in. So I have macros set up for all of that. That makes things so much easier. So now I want to do the bolts. So we're going to go back to steel. We're going to select bolts. We're going to hold down the shift key and open up our bolts. Now the bolts that we're using here, we're just doing holes. We're not doing the bolts themselves. So we're just doing the holes. I want them to be 3/4 inch. So I'm going to select the 3/4 inch. As far as, since we're just doing holes, the bolt standard, the bolt type, the bolt type I don't think the bolt type matters. The threads and the material doesn't matter. The cut length, you just want to make sure that the cut length is at least 2 times, at minimum 2 times the thickness of whatever you're trying to go through. The default is 4, and we're good with that. The shape and the bolt group we'll get to here in a minute. The tolerance we want to change because for the hole itself. Now, since we are drawing the hole, I want the tolerance of the hole to be 0 because I want it to be a 3/4 inch diameter hole. I don't want it to be set up for a 3/4 inch diameter bolt. I want it to be a 3/4 inch hole. So since my bolt size is 3/4 inch, my tolerance would then be 0, which makes my hole 3/4 of an inch. So we got that. Next thing I'm going to do is we're not showing the bolt. So over here there are 3 check marks, which are the default. The one on the end is for the bolt itself, and then the going around here counterclockwise or clockwise we have the nut and then the washer. So we're not going to show the bolt shaft. So if you uncheck that one, it automatically unchecks everything else, because if you're not showing the bolt, you obviously don't need to show anything else. So with that, we will apply. Jump the gun on that. Don't need to apply. Didn't hurt anything. That's okay. We're going to go now back to the bolt group, and what we need to do is set up the shape. The shape in this particular case is going to be a circle, because we are drawing these in a circle. So we set up the circle, and it's going to ask the two pieces of information that we already know, which is what is the number of bolts. In our case, it's 8. And what is the diameter of the bolt circle. In our case, it's 7.5 inches. Now we can hit apply and actually go and put the bolts on. It's going to ask us where we want to pick the part to bolt to. When we do that, we only pick the one part, and we're going to pick the outside, the flange part, because that's where they're going to go into. So we select that, and since we're only doing bolts and we're only doing it through that part, you can then middle mouse click to end the command or to move on. And now it's asking us for the position. So the position is going to be in the center, which is right here. So we give a point there, and then I'm just going to give a point straight up, making sure that it's ortho, and just give a point anywhere outside here. That's going to give us our bolts. So now we have our 8 bolts located in there. But the way that flanges usually go, this is fine. It's a round piece. You can always rotate it to what you need. But the way that flanges usually go is our bolts don't normally line up on the center line like this. If you look at it from a perpendicular standpoint, you know, being the z-axis and the x-axis or the y-axis, and that, you know, everything is true to the world. Normally we will straddle the center line of that to where they are not on the center line. So the bolts not on these imaginary center lines. Like I said, it's all round, so it doesn't really matter, but it does in a way. So what I want to do is I want to take these bolts and I want to rotate them so that the distance, so that in between these bolts we have the center line goes in between these bolts. So our vertical line and our horizontal line will split those bolts. So I'll show you what I mean here in just a second. It might be a little more clear once I get going here. So basically, I guess I could show you this, so that they do this, so that they're on either side. That's what we're looking for. And that's easy to do. You just select the bolts, and then you can select it from the menu. I usually right mouse click and select move special and then rotate. And then I'm going to give my point as being right in the center here. And then as far as the angle goes, we have 8 spaces, and it's 360 degrees. So 360 divided by 8 is 45. So that means each one of these bolts are 45 degrees apart. So if I want to put the bolt in the center, I want to put the center line between these bolts, I need to rotate them half of 45 degrees or 22.5 degrees. And again, it doesn't matter which way. You can go plus or minus. It doesn't make any difference. We're going to go 22.5 and move them. Okay. So that sets up everything on our part. We don't need this anymore. I'm going to set my work plane back to the plan. And that is our piece. Now, this is all separate pieces. There's the flange, the weld neck, the face. We have everything is all separate pieces, and we want this to now be one piece. So what we do is I come up here to the, I guess this is the edit menu. And in the edit menu, there is a command up here that says, or a menu item called added material. And what we want to do is we want to attach the parts. So we're going to select attach to part. So, and this allows you to take and select the part and then attach other pieces to it so that they all become one. So it's asking for the part to attach to, and this is what's important. You want to make sure that you select the main part, and in our case it was the flange here, the main flange. So I'm going to select that. That is our main part, and everything else will attach to it. So now after you select the main part, you just start selecting all of the other parts that attach to it. I just selected the raised face, and now I selected the weld neck, And when you're done, you middle mouse click and everything becomes one part. You can see all of the pieces in here. We now have these cuts or added material pieces, and there's one that goes around the edge of the raised face there. And if I just redraw, all those go away. But now you can see if I hover over it, the whole thing selects. So it's all one piece now. So with that, we have now created this piece as being its own. If I right mouse click and I say inquire part, it comes up as a 4-inch RFWN flange, and it gives its weight, it gives the material, it gives everything about it just as if it was its own part, its own piece. So that is how we create those. You can move this around, you can copy it, you do whatever you need to do with it. That's how you would create an item using profiles from Tekla profiles, or using native Tekla profiles. And there are all kinds of profiles in the profile catalog, so you're not limited to just doing what I did here, but you can do this with just about anything. So and if you can't find a profile that fits your needs, you can create your own using the sketch editor. I believe you can create your own profiles and put them in the profile catalog. You can use one profile and then hack and cut it up as you need to. I can cut these pieces now if I need to while it's still apart. I can cut pieces. I can manipulate these as I need to. So if in this particular piece I wanted to cut out a portion, say over here, I can just come up to my polygon cut and select the piece and then just define a random polygon here. And you can see that it will cut that piece, no problem, no worries. So if you need to do that, you can do that with items that you import in, and you can do that with other things as well. But it's not limited. You're not limited by that here. So with that, that concludes that portion of it, which is the how-to portion. If you guys have any questions on that, let me know. Again, if you're watching in the chat, you can ask me questions right now. We can interact with this as it is right now. If you're watching it after the fact, after it's been live, and you have questions or comments on it, you can feel free to leave those in the comment section below. Again, I do read those, and I do try to respond to them as much as I possibly can. So if you guys have any questions, now would be time to ask. If not, I do have some questions that usually that I get asked a lot, and I'll go through those if that is better for right now. The other thing is, we're going to minimize this for a minute, and let me kind of get things squared around here a little bit. Let's see what we got. Okay. There we go. Okay, and I'm just looking in the chat right now. Anton Swart, what time is it in the U.S. right now? Where I am right now, it is 9:45 a.m. I think you should stream at 4080p resolution of view. I do have I think you should stream it at as 480p resolution, 4K resolution. I do have a 4K monitor. I'm not streaming at 4K right now. I probably will, maybe at some point, but for right now we're keeping it simple, and the camera shoots at 1080p and the stream is at 1080p. It just makes it simpler for right now. Maybe in the future 480p because I know that that's, or 480p, 4K, I'll shoot in 4K, but that might be at a later date. We'll see how all this goes. let's see here. When converting those parts to one part, can you do category parts like the profiles? When converting those parts to one part, can you do category parts like the profiles? I'm not sure what you're asking. If you're asking if I can convert those parts to one part, I don't think you can put those in the catalog. Once you've made them into a part, I don't think you can put them into the catalog. I don't know what that catalog would be. You can, however, once you make them into a part, you can make them into a component, a simple component if you wanted to, and then you can write them out from there and publish them and exchange them with other people. There are advantages to components, doing them that way, simple components. If you used to draw in AutoCAD, you kind of think of those as like a block. If you take and make the item like we did, and then or make the part like we did, and then make it into a component, a simple component. Any changes that you make to that component afterwards, you can edit that component. And once you do that, it will change all of the other components. So that's something else that can happen. There's advantages to doing that. I'm not showing that right now. That gets a little more involved. So maybe in a future video we'll talk about that. But yeah, that'd be about the only way that you can do that. I don't think you can put it in a parts catalog. Do you work with third-party engineers who use software such as SolidWorks? And what is your practice? I do work with other engineers, and I do get other. I mainly what I work from. I don't necessarily get models or things of that nature. You know, I don't get other file formats to insert into Tekla. I don't usually have to do any of that. Usually what I get is a PDF showing the design, the plans, the actual design drawings, and I work directly from those. I very seldom ever get like a SolidWorks model or Revit or any of the others. I very seldom ever get another reference model. I suppose if you want to look at it that way, I don't get reference models. I don't insert reference models. I don't really do too much of that. I mainly just do I generate everything myself, which is usually easier. I usually also do a lot smaller projects, so I don't have big, huge projects that might be where that would be an actual benefit. So yeah. I don't know if that answers your question, but no, basically I don't get other models from other engineers or whatever. And my practice for managing models, wow, that's a big subject. There's a lot of ways to manage the models. I don't do it very well, but I do my best. And I don't. And as far as I guess what you're asking is, what is the practice for managing models that I would get from engineers? Again, I don't do that. But if you're asking in general, how do I manage my models? Not very well. I wish I was better at it. Sometimes they get kind of messy. Anton, Chris, when you were changing an assembly drawing view to be a model view and not local, views jumps vertically down in drawing rather than the drawing with the local. I don't know that I understand your question, Anton. I'm trying to understand it here. View jumps vertical down the drawing rather than the drawing. So you're talking about in the change in assembly drawing view. So you're talking about in the drawing system itself, like if you're in the drawing editor, when you change an assembly drawing, the views jump around on you. I haven't experienced that. If that's the case, I'm not sure. So, good timing. I am off today. Good. I'm glad you could join us. Glad you could join. I've also been asked some other questions, and I'll go over those here. I'm on social media, and I think some of you know that. Some of you are aware of that anyway. I can be found as C.S. Wilson Draws on just about any social media. But I get a lot of questions asked. Usually, I say a lot of questions, I get a few questions asked several times. And so I kind of wanted to go over those right now. These are just some of the things that I need to put something together in case there wasn't any questions asked, just so I had the question and answer session kind of covered here. So some of the questions that I get asked are essentially, am I hiring or do I outsource? And the answer to both of those is no, I'm not hiring. That gets into the business part of it, what I do for a living. This YouTube thing I don't do for a living. This is what I do when I don't have much else to do. I do this as a hobby. In terms of am I hiring, no, I don't. That's not why I use social media. I don't use social media to branch out and try to get to either get work or to find people to work with or to collaborate in that respect with work or whatever. So no, the answer to those, if you ask me, the simple answer is going to be no. And that's fine. I'm not trying to discourage anyone from asking me questions. Feel free to ask, but the answer will be no. The other question that I get asked most often, a lot of times, and I assume this is from people who don't have Tekla Structures, I get asked, how much did you pay for Tekla Structures? How much does it cost? What is the pricing? What is all that? I don't have that information. I know how much I paid for it, but that's been several years ago. And I don't think that that's really relevant to what I paid for it or what anybody paid for it at a time previous. So the best way to find out how much Tekla Structures cost is to contact Tekla themselves. There's all different kinds of pricing levels and all different kinds of, depending on how you have it set up and what you want and roles and your region, all of that. There's all kinds of factors in there that if I were to tell you, it really probably wouldn't mean anything anyway, because you really need to contact Tekla themselves to find out how much that costs. So for those who ask me how much I paid for Tekla, I probably won't divulge that information because I don't think that it's relevant, and I don't want to steer people wrong or give wrong information as to what the current pricing would be, because I don't know what that is. Editor. Have you ever worked with cloud files? I have not worked with cloud files. And I assume you mean files that are up in the cloud, and instead of loading them directly from a disk, you load them from the cloud. No, I haven't done that. As a matter of fact, I use Google Drive to and use their backup and sync. It used to be called, what was it called? I think it was just called Google Drive. I can't remember what the service was called, but they recently changed the name of it. Now it's called Backup and Sync or something like that. So I do have all of my models stored in a directory or in a file, a folder that gets synced to Google Drive, and where there's 15 gigs of free storage, which has served me well for quite some time. And so whenever I do any work, it saves it as I'm working. So that's about the closest I've ever come to cloud files. I actually load them off my drive, so I don't actually get them from the internet, but they do save back and forth. And so anyway, to answer your question, no. And I kind of got off on a tangent there, but yeah, there's a benefit to that, and I can see that, but I hate to have my files all in one place. That seems scary to me. 3D scan. Okay, I meant cloud files is 3D scanning for existing structures, for example. No, I haven't worked for those. I haven't worked with those. Like I said, most of what I get is PDF files, just engineering PDF files, design drawings, and then I work off of those. So I very seldom ever get. I haven't really used any kind of reference model. I play around with them every now and then, but I don't really use them. I haven't used them, so I haven't had a need to use them. So I think that might help. Hopefully that answers your question. Okay, one of the other questions, and I'll just go over this real quickly, and then we're going to have to wrap this up because I do have to, so we'll make this one quick. One of the last questions that I get asked a lot is, do I recommend using the newer versions or the newer version of Tekla Structures? And this is a question that I get asked quite a bit because I think a lot of people, and I don't know this for a fact, I just know from what from what I've been from what I've experienced and what I've heard people relate to me, that a lot of people are using versions 20, 21.1. The versions before newer versions, which is basically version 2016 and up. And so they're wondering, is it, I guess what they're trying to figure out or they're trying to find out, and I can understand that, is it worth going from their version, either 20 or 21, the pre-newer versions, to the newer versions, even up all the way to maybe 2018? And my answer to that is yes, I would actually highly recommend that. I've gone through all of the versions since 19. I started off with version 19, and then I went into 19.1 almost immediately, and then version 20, and then I went into 21, and then I went into from 21. I was at 21 for quite a while, version 21, and then I went into 2016, and I've just gone up from there. 2017, 2017i. And now 2018, I haven't fully switched over to 2018, but I have switched over to 2017. I've done several projects on it. The example I just showed was 2017i. I really like that version. There's a lot of improvements. I did use 2016. If you're going to switch from the from versions 21.1 and before that, if you're going to switch into the newer versions, I would highly recommend that you go with the latest version and not version 2016. Stay away from version 2016. I would skip that. And 2017 I worked on for a long time. Works really well. But if you're going to do 2017, you might as well do 2017i because there was a lot of improvements in that, and I really do like the improvements with it. And then on top of that, 2018 has even more improvements. So if you're going to switch, I would switch to the latest. So that's my answer to that. Should you switch to the newer versions? Yes. And if you are, I would switch to 2018 or whichever one happens to be most current at the time. Okay, I'm going to look here in the chat one more time, and then I'm going to have to get out of here because I've got to get to work. Anton, 2018 SR1 is great. Some small issues, but so far, yeah, I've only messed with that for just tinkering with it. And when it very first came out, when it was first released, I had a little bit of an issue with it. Had some things I didn't understand, and I know other people had issues. I didn't have their issues with crashing and things like that, but I didn't have that. I didn't have any of that. But there were some things with it that I couldn't pull the trigger to switch everything over to that first one. I normally wait until the first service release before I do that. When service release 1 came out, I've just been tinkering with it. It's only been out for a couple of weeks now, and I haven't had a chance to really get into it and figure stuff out. So, but yeah, I would highly recommend it. What I have seen with it is on and above 2017i, which I actually really, really like. I was running into some troubles with China environment in Tekla 2018. I can't find C12.6 profile whatsoever. I wish I could help you out on that. I don't know how to fix that. Your best bet would be to try to, which is my go-to, it's canned response, I know, and I'm sorry, is to get in touch with Tekla Help Support or the Tekla Help Desk. If you don't have a maintenance agreement, then I don't know. I don't know what to tell you. That I'm not sure about. I can only help with things that I've run into problems with or things that I'm familiar with, and I'm not familiar with that at all. So I apologize. If there's somebody else in the chat that can help with that, I would appreciate that. Thank you, Eder. I appreciate that. And well, good morning, but you're just in time because I'm just about ready to end it here. As a matter of fact, I do need to end it. This has gone on probably just a little bit longer than what I wanted to. Again, it's going to be put up on the channel, so if there's anything you missed or if you have any other questions or comments, you can always go back to this from the channel and leave a comment or question. And we'll see how this format goes. I might continue these if there's enough interest and enough people like this format and they like to see more, then I will be more than happy to do that. So with that, I appreciate you watching, and we'll see you in the next one.